Okay, everybody. Today we are moving on to section 2.7. 2.7, we are still going to be looking at factoring polynomial expressions, but specifically, we're going to be factoring special products or special cases. There's two special cases we're going to cover. The first one is called the difference of two squares, and the second one is the sum and difference of cubes. Now, I don't have actual word definitions for these, so we're just going to look at an example so that we know how to identify them. When we're talking about the difference of two squares, an example here would be like x squared minus 16. The first thing we want to look at is that it says difference. The reason it says difference is because it's a subtraction problem. If I were to give you x squared plus 16, this would not work and you could not factor it using the difference of two squares. The second reason we call it the difference of two squares is because I want you to think about a square for a minute. And what do you know about the sides of a square? And I hope you're thinking, okay, well, they're the same length. So if the area of my squared is x squared, then my side length would be x times x, which makes a square. If the area of my square is 16, then my side length would be 4 by 4, which a 4 by 4 square is 16. Hence, the difference of two squares. Okay, that's the way you're going to recognize this specific case. The second one we're going to do is the sum and difference of cubes. And on this one, we would be looking at something like x cubed plus 8 or x cubed minus 8. And on this one, we do get to do both plus and minus. It's going to work either way. Now, the reason we say cubes, and again, I want you to think about a cube here for a minute, which is a three-dimensional square. And if we're dealing with x cubed, it would be x by x by x. If we're dealing with 8, it would be 2 by 2 by 2, in fact, forming a cube. So that's the way you're going to kind of start to recognize the sum or difference of cubes. Now, specifically, let's start thinking about this and how we're going to factor this. Keep in mind, factoring is the opposite of multiplying. So currently, if you look at letter A, x squared minus 25, this is in standard form. We need to get it into factored form. So same rules kind of apply. You look at the first term, is it positive? Yes. And then you look at all your terms, is there a greatest common factor? No. So we're good to go ahead and factor. But this is not a trinomial. This is a binomial. So if I use the rules I gave you, there were 6 steps to factor a trinomial. You'd multiply the first and last number, and then you'd add to the middle number. Well, there's no middle number. And yeah, I could maybe put in a 0 or a placeholder, but it's actually a lot easier than that. So once you identify this as not a trinomial, you're probably looking at going, okay, maybe it's a special case. Let's see if it is. X squared, I can break down into x times x. 25, I can break down into 5 times 5. This is in fact subtraction. So yes, this is a special case. It's difference of squares. So I know I need to get it into factored form. I set up my factors. I take one of my x's, I stick it here. I take my other x, I stick it here. I take one of my 5's, I stick it here. I take my other 5, I stick it here. And then I make one of these a plus, I make one of these a minus, and you are done. Okay, that is factored. The way we check it, x times x, x squared. X times negative 5, negative 5x. 5 times x, 5x. 5 times negative 5, negative 25. Combine like terms, negative 5x and positive 5x go to 0. X squared minus 25. And look at that. You're back to what you started with. So difference of squares, not hard at all. You just have to be able to identify it and remember what's going on. Let's try again. Letter D. Again, I know this isn't letter B. Just pay attention to where you're moving on your paper. 25z to the 4th minus 81. Same as before. Is the leading term positive? Yes. Is there a greatest common factor? I don't think so. So I'm going to look at 25 and I'm going to go, okay, well that's 5. 5 times 5. But what about z to the 4th? Is that really a square? And it is. It's z squared. So we're going to have 5z squared times 5z squared. 81. 9 times 9. Is it subtraction? Absolutely. So again, this is difference of squares. So I set up my parentheses. I put 5z squared in the first one. I put 5z squared in the second one. I put 9 in the first one. I put 9 in the second one. And then one of these is a plus and one of these is a minus. And you are done. Okay, notice this time I switched up the plus and the minus. It doesn't matter. You can put it here, you can put it there, you can put it, the plus could be here, the minus could be here. It does not matter. You're fine as long as one of them is in fact a plus and one of them is in fact a minus. Next one, x cubed plus 64. Is the leading term positive? Yes. Is there a greatest common factor? No. So is it a trinomial? No. So maybe it's a special case. This time I'm dealing with an x cubed. Well, that's probably not difference of squares then. And it's also addition, so it's definitely not difference of squares. So maybe it's the sum and difference of cubes. So cubes means 3. So x times x times x. What about 64? If you've got your calculator, start guessing. 2 times 2 times 2, 3 times 3 times 3. But this one is 4 times 4 times 4. Which means, yes, it's sum and difference of cubes. Now, pay attention because this is how this one works. We're going to set up our factors, okay? But this factor had a bad day. I usually call this like hippo butts, okay? When you have your parentheses, picture a hippo turning around and mooning you with his behind, okay? These are his butt cheeks right here. Now, this particular hippo, he's having a slightly bad day because this butt cheek, he got stung in the bottom by a bee. So I call this the hippo who's having a bad day because one of his butt cheeks is the normal size and the other butt cheek, it's swollen. Okay, so that's this special case. Sorry about that. Okay, now how we fill these guys in is you're going to take one of your x's and you're going to put it right there. You're going to take one of your 4's and you're going to put it right there. You're going to take your other 2 x's. You're going to multiply them back together. You're going to stick them right there. You're going to take your other 2 4's. You're going to multiply them back together. You're going to stick them right there. Then you're going to come up here. You're going to multiply these two together. So 4 times x is 4x. And you're going to stick it right there. Then you're going to go SOAP, which stands for same, opposite, always positive. Now, what I mean by that, you come up here, you go, oh, that's a plus. Same, put the same sign. Then put the opposite sign, and then always positive. And this is done. Okay? Now, because this is the first one we're doing, we have to check it. We have to know that what we're doing is actually correct. So I'm going to come down here, I'm going to rewrite it. We've got x plus 4, and we've got x squared minus 4x plus 16. If we're going to multiply this out, this is a binomial times a trinomial. So we're just going to distribute, or you can use your table, but I'm just going to distribute. So I'm going to start with my x times my x squared, x cubed. X times negative 4x, negative 4x squared. X times 16 plus 16x. 4 times x squared, positive 4x squared. 4 times negative 4x, negative 16x. 4 times 16 plus 64. Then we combine like terms. X cubed drops down. These guys cancel. These guys cancel. Plus 64. And that is what we originally started with. So we know that our factors work out. And again, x cubed plus 64 is our standard form, and then the x plus 4 times x squared minus 4x plus 16 is our factored form. Okay, letter E, 8y cubed minus 125. Leading term, yes, it's positive. Is there a greatest common factor between our 8 and our 125? No. It's not a trinomial, so again, I'm looking at it going, well, maybe it's a special case. So if it's a special case, I'm either looking for squares or cubes, and given that that's a y cubed, I'm thinking cubes. So 8 is going to be 2y times 2y times 2y. 125, I don't care that it's negative. Ignore the negative. Just look at 125. It's 5 times 5 times 5. So yes, this is the difference of cubes. So remember, small butt cheek, big butt cheek. Your hippo's having a bad day. One of your 2y's, one of your 5's. Other 2y's, multiply them back together. So 2y times 2y is 4y squared. 5 times 5 is 25. Do you remember how to get the middle term? Multiply. So 2y times 5 is 10y. Then we go back. Look at your sign. Same, opposite, always positive. And you're done. Okay? Now, in doing that, go ahead, check it, multiply it out just like we did the last one, but I'm going to move on. So last example here, 16d squared minus 54. Leading term, yes, it's positive. Greatest common factor, I think there is one. So my first thought here is I'm thinking 2. So we have to take it out before we get started. Okay, so I'm going to take out the 2. What's left over? 8d squared minus 27. And now I'm looking at what's left over here. It's not a trinomial, so now I'm kind of looking at, okay, well, maybe it's the difference of squares. D squared would be d times d, but 8 would only be, 8 doesn't have a square. Well, what about 27? 27 is 9. 27 doesn't have a square. So maybe this would be cubes. This can't be factored because it's not cubes. So I think I probably have a typo here. Can't be factored. And on this one, you're done. Okay, now let's go over here and do a but, because I'm pretty sure your teacher made a typo. But what if I had given you 6d cubed minus 54? Okay, let's see what would happen here. Still going to divide by 2 for the same reason as before. Then I'm going to have 8d cubed minus 27. Okay, well now I'm looking at it, I'm going, okay, well it's definitely not squares anymore because it's not d squared, but what about cubes? So this 8d cubed would be 2d times 2d times 2d, and 27 would be 3 times 3 times 3, which means we could actually do cubes. Okay, so then this, small butt cheek, big butt cheek. Take one of your 2Ds. Take one of your 3's. Take your other 2Ds. Multiply them back together. 4D squared. Take your other 3's. Multiply them back together. 9. And then multiply your first 2. 6D. And substitute in the middle. Look at your original sign. Same, opposite, always positive. And then on this particular case, don't forget your greatest common factor. So we're going to take our 2, we're going to put it down there in the front, and this would be factored. So if, and don't forget about that 2, I don't have it in the box. If I had not made a typo on that, it would be cubed, and we could do this over here on the right. But if I were to give this to you on a test or just in general, you can't go any further. Over here on the left, this can't be factored, and you'd be done.